Hello, my name is Mark Gwynn. I'm one of the inspectors with the Utah Division of Oil, Gas, and Mining, and I would like to talk today about the Inspection Prioritization Program that we've recently initiated. This program is a partnership between the Utah Division of Oil, Gas, and Mining and the Groundwater Protection Council, whose help we greatly appreciate, and without that help, we wouldn't have been able to get to where we are. And you'll see a little bit about why that is here in a few minutes. A number of players are listed there at the bottom that played a part in this as well, and like to point their efforts out along with a number of other people that aren't on there. So, as a regulatory agency for the oil and gas program, we really want to see well locations that look like they do over on the right versus what we see on the left. The left was a spill that was noted last February, about 375 days after the last time this inspection or this well pad was inspected. That tank in the background there is about 425 feet away, and you can see a pool of oil, a stream of oil. It's running clear down to this location, and we estimate that was about 50 to 70 barrels of crude oil, and that is kind of the reason of why we do what we do. All right, realizing that a lot of people watching this are not oil field people, let me just give you some sort of an example of what an oil field looks like. Bear in mind that oil fields in some locations do not look like this, where there's many pads. Those can be seen over here on this collector map. They're a little bit small to see, but all these dots are oil wells that are out there. What does that look like in the field? Well, there's an oil pad with 3 wells on it, all right next to each other. In this photograph here, there's a number of arrows. Those arrows actually show where you can see oil wells from my location there. There's about 19 that you can see if you were to blow this picture up there. The ones with the numbers are ones you can see. Some of the ones without the numbers there that correlate on the map are off the edge of the map. They're just way out there, more than 1.5 miles away. Bear in mind also that what we can see on these locations, on most of them, there's 1 or 2 of these production wells with a traditional pump jack out there. A lot of them have, and some of them only have, smaller injection wells where it injects water that comes out of the ground with the oil back into the ground. And those you can't really see because they're usually just covered with a small shed. There's no pumping unit because we're just putting stuff back in the ground. So to give you a little idea of what the field looks like, again, many fields are spread out a lot more than this. But up in the Uinta Basin, where most of our oil production takes place, it's kind of what a lot of them look like. And by the way, this is the Monument Butte oil field, and it's a little bit south of the town of Miton. Okay, the mission of the Utah Division of Oil, Gas, and Mining, it boils down to encouraging responsible reclamation and development of oil and gas resources. We want to protect correlative rights. We want to prevent waste, and we want to protect human health and safety and the environment, and basically produce things in the interest of the state and of the citizens of the state. And that's really what our part of this comes down to. So we've got another example of kind of a bad location there, a lot of mess and some spills and everything else. We want to avoid that kind of stuff. We want to kind of keep with this nice clean picture there. So we have some inspectors that go out and do this. Now, we have a lot of responsibilities for these inspectors. We got to look at spills and incidents response, compliance issues, plugging of old wells, complaints typically from citizens, testing some of the wells, completions of new wells, pre-drilling inspections. So when an operator wants to drill a new well, we've got to go out and look at the location. Cement tags when they're completing a well or plugging, remediation and reclamation monitoring, and number 11, routine compliance inspections. And that's kind of what we're really focusing in on here, is just keeping an eye on those wells and making sure they're in good shape as they go through operations. So in our division, we have 7 what I'll call full-time inspectors, and that's what they're mainly doing in their day-to-day work. And there's 2 or 3 of us at the same time that are kind of part-time inspectors. So we're kind of doing some other things a lot of the time, and not so much these routine compliance inspections. So out of about 7,000 wells we're responsible for, that's a pretty big workload, roughly 1,000 wells to look at every year. And in the case of certain wells, we want to look at them even more frequently than that. So again, that's what we're trying to do with this program, is make us more efficient. So what the system does, it maximizes an inspector's knowledge of their particular area of responsibility. We still want to use their expertise and draw their attention to the right place at the right time to more efficiently accomplish our routine inspections. One of the ways that we can do this is to use this system to navigate where we need to go. So I'm getting a little bit ahead here, but this is kind of what our system does. It basically classifies these wells with color code depending on what their priority is. And we can sit back then and kind of figure out in a day's work where we want to go and how to get to those wells and be the most efficient that we can in looking at the wells we need to look at. What this system is not designed for, and it's not intended, is to create a rigid daily workflow for a given inspector. Our inspectors are pretty well know their areas. We're pretty experienced in general, and we really want to capitalize on that knowledge and not just make this a rigid, this is where you need to go today. We need to use our judgment still in what we're trying to do on a day-to-day basis. But this is something that this program can help us to do that. And that's what its main intent is for. Let me give just a little bit on the development history. This concept was hatched within the division around 2014 to 2015. Some people looked at that and said this would be something really good to do. But at the time, not really enough people with the experience that we needed to make that come to fruition, and not enough time to really do that. Interestingly, the Groundwater Protection Council was kind of thinking the same thing around 2014 to 2015. In late 2018, they contracted with Jim Milne, and he did kind of a proof of concept study using real GIS data from Duchesne County, which is in here. That's where, a big portion of the oil wells in the state, oil and gas wells, are located. So that was pretty good. That was a good basis for us. Because of that, we formed a partnership with them. We started planning in the spring of 2019. We had a program ready for testing in December 2019 with some changes from what the original concept study, proof of concept study that Jim did. And we were ready for testing in December of 2019. We had it operational in late January of this year. Started having our inspectors use it, found it to be pretty useful. Since then, we've added several capability updates. Now we're able to improve our work even further with a little bit of some of our testing and initial use. And we've got a number of other things in the works that that I'll touch on a little bit briefly as we go along here. So one of the main things that we added from the proof of concept version is that we wanted to add some operational factors. So things like outstanding compliance issues with a given well, if there's been some leaks or some problems that we've had to work with the operator to correct. What that history is, if it's a long history of numerous problems. The days since the last inspection. So our inspection frequency is kind of an important driver there. The average monthly production and the age of the well also kind of tie into, what the risk with that well is. Again, we have had sort of a draw on that original test setting for geographic factors. So we look at some things like population centers, the occupied structures, primarily how we do that. And these are things that as somebody doing permitting work, these are some things that we look at when we do the permitting, because we're trying to evaluate risk before we even put that well in there, and try to mitigate potential problems before we get to them. So streams, lakes, wetlands, water-related land use. So if there's an agricultural area and we have a spill or some kind of an incident there that impacts agriculture, that's a problem for us. We obviously don't want to have any problems with public water supplies or domestic water supplies. The permeability of the soil plays into this, and the slope, because those play a role in how far a spill or some kind of an incident would range out from that well. And then we also have some looking at the wildlife habitats in there. From a development standpoint, both the geographic and the operations kind of follow the same pattern, but we don't need to do a couple of steps on the operations side. So we're going to start by assembling relevant GIS layers. We're determining what of the operational things are important. On the GIS side, we got to create some buffers. I'm going to show these a little bit more detail in a minute. We're going to figure out how to intersect our well locations with those buffers that we've developed. We're going to transfer that GIS Intersect data into our general existing RBDMS database. And you don't need to remember RBDMS. That's just our overall well database. Then we come to where we execute the stored procedures into a model, calculate some of the scores, and those are outputted into a map, or if we want, into a. So again, we've just talked a little bit about some of the operational criteria. It became useful in forming our model to build these into groups. So we have a compliance group, an inspection status group, and a well history group. Compliance and inspection status are the most important drivers for developing an operational score, with a little bit less emphasis on the well histories. Again, these are the steps, and we're going to look at more, obviously, for this purpose of this presentation, at the geographic factors. So again, we broke these into groups. So our population groups, our surface water groups, and our groundwater group. The wildlife areas, for example, the critical sage grouse and Gunnison sage grouse habitats, we also look at those. They don't really build into the score, but they are available if they apply, so that an inspector is aware of those kind of things, and we can act accordingly. So those are all pretty high ranking in importance for this part of the models. So step one, we want to assemble our layers and operational criteria. We've kind of already done that. We've picked out the things we need, remembering that geographic priority factors are generally static or slowly evolving, but most get updated periodically. The operational factors are often changing from day to day as people do their inspections or things happen on the well site. We also know that new data sets might become available that we would want to use in the future. And so our program is designed that we can easily make those changes or additions. And I'm going to talk a little bit more about it as we go. So just as an example, step two, we create our simple buffer. So we have a perennial stream here. We actually have two buffer distances that we use on here, which are not quite reflected. What we finally went with are not quite reflected here, but you basically build a buffer, in this case, 100-foot and a 300-foot buffer around the stream. And then if a well is within that buffer, it's going to trigger part of our scoring. Another example is water wells, domestic water wells. We basically have a mile, 1,320 feet buffer around those. And we look at whether or not an oil, gas, and well is within that. And if it is, how many is it with of those areas does it intersect? Which I just kind of talked about there. So we've got an intersect, and we've got a number of counts of how many wells it might intersect. So this one, in this case, it's a yes or no, and here we add a count. Now we're going to stack all that data together. So in this example here, we have an oil and gas well here. We have some streams. We have a number of different GIS data sets here. So we've got address points, we've got stream buffers, we've got lake buffers, we've got water wells, and we've got some information on the alluvium or the soil that's out there. And we basically kind of drill through this data with where that oil is, or that oil well is, and use that to generate our model and generate our score. So those steps 4 through 6, we're kind of processing the data and outputting it. So our operational database of information daily, it is updated nightly. We can run queries for that. It pulls that operation data out and puts it into a score results table. Again, we've done the same kind of thing with the geographic criteria. That's gone in there through the GIS model. Goes into here. It does its mixing and matching with data that's in there. It runs through the score models, and then it assigns priorities and spits them out into a map layer or a tabular kind of a report. So just a quick example of the scoring example. For a given well, we have, in this case here, 24 items to be scored. So these blue areas, these ones at the top that are OP, are some of the operational groups. So again, compliance, inspection status, well history. And then these that are down here in this kind of orange are the geographic factors, or geographic groups: population, surface water, groundwater. And they run through on a given well, in any given well, and they kind of spit out a score based on the factors that we have there and the values that we've assigned to them. And again, we have an architecture that we can change these and tweak them as needed if they're not giving us the information we want. And we've got some things that we may change a little bit in the near future. They'll spit out a score and a priority. Now, out of each group, the highest priority there is what will come out as the operations priority, or in this case, the geographic priority. So we have a 3, and a 1. So an operational priority for this well would be a 1. Down in the geographic side of things, we've got a 1, a 2, and a 1. So again, the highest is a 1. So our geographic priority comes out as a 1. Those all kind of go into a Punnett square matrix. So if we have a geographic priority of 1 and an operational priority of 1, that makes our overall priority a 1. And so this is a well that we want to get out and look at pretty quickly. Becomes a higher priority for us to go out and have a look. So where is this program? Well, we have a tool that's actually open source or open to the public on our website called this Data Explorer. And there's, like I say, there's public access, but the inspection prioritization part requires a login. Now, that's not to say that there's not a lot of other oil and gas data that's available to people to look at, but to get to the stuff we're looking at, we need to have this login. Here's kind of an example. This is from our initial release, and there's been a few changes to how things look. But we can bring up these layers, and at this time, we could bring up our overall priority, we could bring up operational priorities, and we could bring up geographic priorities. Again, we have the color of dots on those wells correlate to what those priorities are. And then we can bring up some information on it. We can click on one, it can bring up the name of the well, what we call the API number, which is a reference number to them. We can look at what the different types of priorities are in the overall one, and some information such as when that well was last inspected. Now, we realized after we got going on this that people look at red and these red dots as bad. And it's not really that they're bad. What it just means is we need to get to them sooner. And it's just a prioritization thing. So, we should be careful not to look at a picture like this and say, well, this is pretty bad. There's a lot of red dots out there. No, it's just an area we need to focus on some of these red wells before we do inspections on the other ones, because the chances of them being a problem for one reason or another are a little higher. So this is a risk-based kind of a program. We could also, in the past, we could also look at, by changing symbology, what the priorities are operationally, or we could look at them by what the geographic priorities are. We could also look at this where we have location abandoned or plugged and abandoned wells. We had some other symbology. And just to help our inspectors, if they've been to a well within the last 60 days, those are highlighted in a different way. Now, in our initial use, we realized that really the operational or the overall priority is really all that our inspectors needed to look at. So we've made some changes to that that I'll touch on in a minute. Now, we could bring up the well here, and we can bring up a whole wealth of tabular data on that particular well, including our inspection priority data. And we can also, So in here, for example, we can look at what the overall priority is, the operations priority, the geographic priority, and so on. And we can just look at all the factors there that drive that in there. And then we can bring these things out as a tabular report where we can filter it, we can sort what we want to see, and we can export it as a CSV and then use that in some of our planning. In phase 2, we've had some additions and changes. Again, we've designed the program to be able to change and modify easily as we need to. One of the things we now have is we've integrated with mobile devices using Esri Collector. We've simplified how the inspection priority symbolization works with some of those things that I kind of mentioned there before. Changed some of the colors, eliminated the priority 4. There was only a handful of wells that hit that priority 4. We've kind of simplified some things there. Our newer version adds surface facilities. So these are waste disposal facilities that deal with oil and gas waste products. We've also added some ability to track incidents such as spills and assign those priorities, and also to track the history and remediation of them. And we've actually done a little bit of changing with some of these other, how these other layers are shown. We have a bunch of future plans still for this. One is that we're going to bring up a dashboard or build a dashboard. And that might look like something like this, where we can look at the number of priority 1, 2, and 3 wells, look at a count, and just figure out where we're at on a day-to-day basis. Those can be mapped out here, and these would all be interactive. We can look at the number of days in a given area since an inspection, and pick out areas that we need to work on. So these are some things that are coming along. The thing we're working on right now is to be able to go out in the field and enter our inspections in the field at the time we're doing the inspections, rather than write things down, make a bunch of notes, have to come back to the office and enter those things in the database. That'll be using Survey 123, and we're kind of in the testing phase with that. And I'm going to talk a little bit more about that in a few minutes. Again, we've added some compliance tracking, or we're going to add some more compliance tracking. Area of responsibilities. This idea would be that an operator or somebody from the public could go into an area that they know that there's a problem, where the operator is looking for to schedule some testing. They could go in there, they could figure out what who the assigned inspector needs to be, and they could initiate some contact with them. We intend to be able to use some more permitting functions out of this later on in some ways that I think will help our efficiency. Some of that would allow operators to understand what we're looking at from this permitting standpoint and make their operations a little more efficient by not selecting well sites that we're going to have a problem with. And that saves both them and the division some time by not having to go in there and correct a bunch of things and ask them to make a number of changes to a proposed well. And then all kinds of other things. Really, the sky is the limit with this program. As we go along, we can add things that we maybe haven't even thought of at this point. So let's just talk about typical use by field inspectors. Kind of a typical use is bringing it up in the office and kind of planning your day out there, looking at some areas as our inspector here is doing. And now he's gone out to the field. He's maybe used the system for some navigation. Again, he might use it for offline inspection entry and other purposes. So that's kind of where we're headed with this. And it really is increasing our efficiency as we go along. So I'm going to use a little bit of an example that I did just the other day, partly just as some testing and partly to have some real data to show here. So a lot of our areas are out of cell service. Now, right here, you can see that I did have reasonable service. But a lot of times, in fact, not very far from here, you lose that service. And so we've got to have some offline maps loaded. So this is a screenshot of our program in Collector on my iPad. on here, I had some higher priority wells here that I wanted to go look at. Here I am. Here's my location here. I'm using it to navigate. I can see I've got to turn right here in just a moment and come up to these wells. So this is my offline map. I click on one of these wells. It gives me some basic information on there. Again, we've got an overall priority, operational priority, geographic priority. Again, those things go into our matrix and spit out that it's a high priority location. So now I've arrived at the site. There's 3 wells on that location. There I am, pulled up on the location. So now I'm just going to touch on a little bit how we're going to use offline inspections using Survey 123. Right now, we're kind of in the testing and development stage. So what that's going to mean is that we're able to import the well information from our database, but we can't enter the information and then export it back to our database at this point. That's coming soon. So at the moment, I've still got to go back to the office and get on the computer when I've got connectivity and put that information in so it's in the database. But we're changing that soon. It'll save time and it'll improve our data management, because in the past it happens that our operators, or our inspectors rather, get really busy with things, and sometimes we just forget to get some of those things entered in the database. It happens on occasion, and we don't want to miss that. We want to make sure that that information gets put in there. And Survey 123 and these offline capabilities are going to help us with that. So now I've gone, let me go back so we can click on this link here. It'll open up Survey 123. It'll open up some of the information on the well. There's the API number. Eventually, it'll show us operator name and some of this other information. Now, it basically works with a bunch of pull-down tabs. So we have some built-in inspection categories. I'm not going to show them all on here because I'd have to take too many screenshots. But we can look at some of the basic well information. We can look at containment, and some of these are just a yes or no. Click on yes or no, and we're done with that section. Are there any leaks or spills? Waste management issues, possible environmental issues, housekeeping, which basically means is the well site clean and free of hazards and being well kept. Things like we might look for would be like weeds that could create fire hazards during this time of the year when we've got a lot of range fires. And so we want to look at some things like that. Is this a follow-up inspection, or do we need to do some follow-up? It also gives us the capability for some pictures. So here's a picture of one of those wells out there of the wellhead, and it's pretty clean. There's not too much on the ground. So this actually location is in pretty good shape. And I can put some notes in there as well. And eventually these will be able to translate right into our database as long as we're back into cell service. So it's all stored and we'll enter there. So that's going to be a big deal for us. Now I want to just talk about that particular well and why are these 3 wells priority 1? The operations priority was a 2, the geographic priority was a 1. And remember that whichever of these is the highest is going to drive the overall priority. So these are priority of 1, an overall priority of 1. Going back here quickly, for the geographic things we're looking at, there's a population group, the surface water group, and a groundwater group. So I'm going to talk about a couple things on here. If we looked at all those things for this well, we brought up the tab and looked at them. What we can see here is that wells draw, which is a pretty good size intermittent stream. I've got a photograph here taken with an app on my phone that gives me a lot of other information. It's a pretty good drainage system here, and it connects to waters of the state. So it's a high interest item or area. And so right now it's dry, but you can look around here and you can tell that at times that flows a lot of water through there. It's within 300 feet of the stream. It's within that 300-foot buffer. And so that well becomes geographically a high interest item. In cases like this, even though we inspect them, that's going to remain kind of a high interest item because it's always going to be near that stream. Other wells that are driven to priority 1 more by operational kind of issues, once we've inspected them, they may drop down in priority, which is kind of how we want what we were trying to accomplish. But wells like this that are near environmentally sensitive kind of locations and situations, obviously we want to be able to look at those more frequently. And so they're going to stay at a higher priority all of the time, even when we've been out to them recently. They may drop one or two levels, but they're not going to drop too low, just depending on how that matrix works out. So this prioritization program is forming the framework for adapting it to other programs in the division. So our abandoned mines reclamation program may use it, our coal program and our minerals program may use similar programs to help their inspectors within their division. And there's some interest in other states, other oil and gas inspection agencies in other states that may want to be able to use this as kind of a framework. And with our funding and our partnership with Groundwater Protection Council, that's certainly something that we're interested in pushing through and helping with. And that brings me to the end of this presentation. So what we wish to do with this presentation is enable other inspectors and other agencies to use this kind of a program to help safeguard our environment. We know that energy production is still important to us in the oil and gas field, or in that oil and gas realm. And so we want to be able to do this responsibly, and we want to help other agencies to do that as well. So if we can help you with anything along those lines, please feel free to contact myself, Mark Gwynn, or Michael Van Hatten, or Bart Kettle, all at the Division of Oil, Gas, and Mining. Thank you.